January webinar in our Best Practice series, sponsored by DataKinetics. So I'm Leah Manzoor, as Sheena had mentioned, and I'm the Vice President of Sales for DataKinetics, and I'll be your host for today. So in this webinar, we'll be discussing quality assurance for DB2 SQL and its increasing complexity. And then we'll also address the challenges and performance issues and also recommend some best practices as well. So before we get started, I just wanted to thank everybody in advance for sharing a part of their day with us. So let me tell you a little bit about DataKinetics. So you're only going to get about a 2-minute infomercial, so bear with me, and then we'll pass it over to Craig. But DataKinetics was founded in 1977, and we've pretty much been solving IT problems and reducing IT costs for the proverbial who's who of the Fortune 500 for about 35 years. So we have a dedicated team of folks that deliver enterprise solutions to the most challenging of problems. And these problems tend to be the biggest, the nastiest, the ugliest applications out there. And we actually improve their performance many times upward of 98% faster. So we're an established leader in the data access optimization space, and we have unique products that address optimization of application performance using in-memory processing. And we also optimize data movement, data integration, and database performance as well. So as you can see, we're a privately held company based out of Ottawa, Canada. And we also have regional offices scattered throughout the U.S. We're a long-standing IBM Advanced Business Partner, and we have an international customers that span the Global 500. So as you can see, 20% of the Fortune 50 already use our products, and this includes the top 3 of the top 5 banks, 3 of the top 5 credit card processors, and 3 of the top U.S. property and casualty insurance companies, as well as the largest healthcare companies in the U.S. And so we have the largest, or the second largest company as a customer in these different primary vertical markets. And these are all top long-time customers, and we've actually been helping these folks out for a combined total of about 1,000 years. So we have actually over at 100% retention rate for all of these customers. So as you can see here, our customers are the virtual cornucopia blue chip companies, and these companies just don't trust anyone with their mission critical applications. So some of the challenges that we've helped these companies with is fraud detection and alerting, consolidated financial statement processing, loyalty program detection with rules on the fly and in real time, and also the enablement of big data analytics for BI and for cloud migration. And as well, we help these folks with the maintenance of their older legacy application as well. So we power, our DataKinetics products power over 1 billion mission critical transactions every second of every day. So let me repeat that, that's kind of important. So every second, DataKinetics products process over 1 billion transactions. No small feat. So with these customers, we actually allow them to save billions of dollars every year. And we pretty much do this by reducing the cost of transaction processing, also reducing the cost of data movement, and reducing the cost of DB2 data access. So we can save significant money on your current OpEx spend, and we can actually help eliminate CapEx spend as well. So with that, it's my pleasure to introduce Craig Mullins, even though we know he's a man that really needs no introduction. But Craig is the author of the DB2 Developer's Guide. He's also an IBM Gold consultant, and I'm sure you've run into him at many of the IBM conferences over the years. But with that, and with no further ado, I'll turn it over to Craig.
Thank you very much, Leah. And thank you to DataKinetics for the opportunity today to speak to everybody about DB2 SQL. What we're going to look at today is kind of a a market analysis of where DB2 is today in terms of SQL. We'll look at some of the issues with complexity of SQL and the growth of SQL. We'll examine static versus dynamic and look at some of the drivers that are causing organizations to increase dynamic SQL usage. And then we'll look at some of the performance issues around dynamic SQL without really digging into a how-to or an overly technical discussion of it. We'll talk about access paths and migrations and bind options, and then talk about a couple of solutions that DataKinetics offers to help you sort of wrangle your unruly SQL. That's QA and QA+. And we'll get into that after we take a look at the overall market space. So let's start at the beginning. What are the various types of SQL that we can encounter, and how complex does it get when we really just say SQL? Now, a lot of people think SQL or SQL, and I know what that means. That's pretty simple. I'm getting access to data. But when you really look at what SQL is and the types of things that it offers, you can break it down into 4 broad categories in terms of functionality, execution type, existence, and dynamism. And each one of these, you can have multiple combinations. So with functionality, we're talking about what are we trying to do with the SQL. Is it DCL, DDL, or DML? Where DCL, or data control language, controls security of access to data. DDL, or data definition language, controls how we build and modify our database structures. And DML, or data manipulation language, is our selects, inserts, updates, and deletes, actually getting access to the data in our database systems. And all of these things are SQL. Now, for the most part, as we build applications, we're focusing in on DML. But the SQL language comprises all of this. The DCL, the DDL, usually handled by database administrators, while DML is typically handled by application developers and coders. Next, we look at the execution type. SQL is a very flexible language, so we can have planned and unplanned SQL. Now, that's a lot different than, say, an application programming language like Java or C#. They rarely you can have anything that's unplanned there, right? You got to sit down and actually do a lot of coding and compiling and get that thing running. You're planned for the most part. SQL is pretty easy to sit down, fire off an SQL statement in an unplanned ad hoc manner. Whereas before it goes into production, hopefully, we've done some planning around it and done some tuning and management to make sure that what we're moving into production actually is going to run effectively and appropriately. Now, I say hopefully because in this day and age with dynamic SQL, which we'll get to in a minute, taking off, sometimes that planned nature isn't quite as planned as we'd hope it to be. Next, we have existence. This is kind of a corollary to the execution type because you could have embedded or standalone SQL. Standalone meaning we're running it through some sort of a DB2 spoofy interface or some kind of report writing tool, maybe QMF, and that's kind of standalone. We aren't really coding a program to go around it. Yes, in order to run standalone SQL, there has to be some kind of a program out there that gets the SQL and executes it, but it could be as simple as spoofy. Grab the SQL, run it through DB2, send back the results. Embedded means we're writing SQL that's going to be put into an application program, something that we are writing for our organization, or maybe something that was written for our organization by another company, an ERP package, a CRM package. Finally is the dynamism of the SQL statement. There's static and dynamic SQL. For many, many years in the DB2 for Z world, the vast majority of the SQL that was running was static SQL. at least in terms of the embedded production type of SQL. This was true because in order for static SQL to run, it has to be bound, and in order for it to be bound, the access paths get predetermined. Goes through the optimization process, and out the other end come optimized SQL statements. And if you look at the plan table, you look at the output, you can see what DB2 is going to do in order to satisfy that SQL request. So static SQL was the preferred type of SQL by DBAs pretty much across the planet. The other benefit of static SQL is that it's not going to change. You're going to write it, it's going to be in the SQL, it's going to be in the program, and you're not going to be able to modify what that SQL does at runtime. Dynamic SQL, on the other hand, is basically the exact opposite of everything I just said. It's changeable at runtime if you want. The same, you can build a statement in your program and run it one time. Next time you run it, it's a completely different statement, accessing different columns, accessing different tables, different predicates, different host variables, and so on. So it's changeable, and that makes it difficult to get a handle on in many cases in terms of performance management. The other thing about dynamic SQL is that the access path to the data is determined at runtime. If you think about it, it'd kind of have to be, right? If we aren't even sure that the statement's the same from time to time, how can we predetermine how we're going to access the data? So with dynamic SQL, we do the prepare, or DB2 does a prepare when we issue the SQL. It gets access paths at runtime, and really we don't know what those access paths are beforehand. Now with the dynamic statement cache that was added several releases ago, and most people using dynamic SQL use the statement cache, you can snap the cache, you can explain the cache, you can see what access paths have been chosen. Additionally, if the dynamic SQL statement isn't changing when it runs the next time, it can pick up the pre-bound, pre-prepared information from the dynamic statement cache, and dynamic begins to look a little bit more like static. Not exactly, but a little bit more. So things are being done inside of DB2 from version to version and at IBM in order to make dynamic not as troublesome as it was in the past. Now there are other reasons why dynamic is becoming more pervasive than it was in the past, and we'll get to that in a moment. The other thing that is happening right now is that SQL is getting more and more complex. Now, this can be a good and a bad thing. From a performance perspective, as a consultant who focuses on DB2 for Z, it sort of does my heart good to hear SQL is getting more and more complex, because I've been preaching for years that you should put the work into the SQL, and that means you're creating more and more complex SQL. And the reason you do that is because DB2 has a better chance of optimizing the access to the data than you do by breaking it apart and running it separately inside of your program. But that's not really what I'm trying to get at here. What I'm trying to get at here is that the SQL language inside of DB2 is adding more and more functionality and more things that you have the potential of being able to code, which makes it more difficult to understand, more difficult to debug, sometimes more difficult to code. There's the dynamic versus static that I said we'll get to in a minute, but there's also, even early on in DB2, there were multiple ways to code SQL and get the same result. Code a table join with a comma-separated list of tables, or with the on clause. Both of them are going to return the same results. Sometimes there are multiple ways to code SQL statement with different types of verbs. You can use a subset, you can use a join. Different performance can result from different formulations. Over time, the optimizer is getting more and more smart, where it does code translation so that when it optimizes things that are trying to produce the same results that many times can produce the same access paths, but not all the time, and that can be a complicating factor in terms of coding appropriate SQL and ensuring that your developers are coding appropriate SQL. Then there's those new functions, right? OLAP functionality, temporal support. These are new in the past couple releases, version 10, version 11. And if you haven't dug into the manuals and taken a look at, what is this OLAP function? How do I write a temporal query? Then you see these things for the first time, they're going to be jarring. They're not going to be something that you can quickly pick up and say, oh, I can do this without any education. And it's not just OLAP and temporal. If you look at this green section in the middle, this is kind of a high-level overview of the new stuff that's been added to SQL in DB2 versions 9, 10, and 11, the past 3. And you can see some things here that may or may not look like things you've dealt with in the past. Have you done XML? XML putting into your SQL can make things very confusing. How about something like intersect or accept? These are new verbs that are added to SQL a couple releases ago. Table functions, implicit casting, row numbers, transparent archive query, Hadoop access. The more and more we add and cram into DB2, it's a good thing because it makes DB2 more flexible in terms of supporting our application needs, but it's also a complicating thing, making SQL very complex. So yes, confusing, difficult to learn, easier to create poor performing SQL, but it's not like we want to say, hey, slow down, stop adding things to DB2, because we want DB2 to be modern, up to date, and allow us to access big data and analytics, IDAA stuff, Hadoop stuff. So this is something that's going to continue. Our SQL is going to get even more complicated. And complexity is only one issue. Even simple SQL can be coded wrong, and I put wrong in quotes because it's not wrong necessarily in terms of returning wrong answers, but you can write SQL that's wrong in terms of causing performance problems. I talked about putting work into the SQL instead of the program. That's what we should always be trying to do from a performance perspective. Now, maybe from a ease of use perspective, if we haven't trained our developers, we want to make the SQL as simple as possible. And okay, if you're doing that with a clear head and you know what you're doing, and you're saying, I don't care if performance suffers, I'd rather have my code easier to understand, then breaking things apart and smaller SQL that's less complex can make some sense. But rarely do I have organizations that are willing to bite that bullet when I'm out talking to them about DB2. Retrieving only the minimum number of rows and only the columns required. Things like the relational mindset, where people move to DB2 from working on flat files, and they try to use DB2 just like their flat files. This is bad. This is what gives DB2 a bad reputation. Saying things like, oh, DB2's a pig and it's going to eat the lunch of the CPU. Well, if you use it wrong and treat it like it's not a relational DBMS, then yes, it's going to do that. But learning how to do it, joins, proper join predicates, no Cartesian products, understanding what stage 1 and indexable predicates are, using them as opposed to stage 2 and non-indexable, not going overboard and saying, I'll never code a stage 2 predicate, and then causing you to write exclusion logic in your program. Well, that's even worse than using stage 2. Avoiding scans. This involves making sure that you are explaining when you're using your SQL and looking for scans, and looking for ways to use index access, avoiding sorts, multiple ways to avoid sorts with order bys and group bys, having indexes to match them, not using distinct unless you really do care that you want to sort to remove duplicates, and using union all instead of union. Union sorts to remove duplicates, so if you won't have duplicates or you don't care if there are duplicates, use union all and it's going to perform better. General rule of thumb, though, is that you want to be identifying and remediating problems as early in the process as possible. The earlier you do it, the easier it is to correct it. The less overall the project is going to cost. And these are good things, right? We want to make correction of problems simple. We want to reduce the cost of projects. So we want to have automated ways of hopefully remediating problems, of ensuring that our code is written according to standards, according to best practices, according to industry and shop standards. Bad SQL, don't think I'm saying anything that anyone doesn't understand here. If you have bad SQL, you can increase the risk of having customer-facing applications give subpar performance. And if the response time is bad, your customer is going to go somewhere else. You probably heard that before. This press release from Akamai, they did a study. It said that 2 seconds was the new threshold. You have to wait longer than 2 seconds, someone's going somewhere else. So you want response time under that. You want your SQL performing appropriately. Let's look at some of the bind and rebind essentials that are used to create DB2 packages. I'm not going to dig into this list and one by one read it to you. Basically, this is up here as a point of reference to show that when you do binds of packages, programs in DB2, there are a lot of options to choose from. You can choose from things that will cause you to get information versus not information about the plan table, the ACID level of your transactions, the durability and the locking, the optimization, whether or not you're using hints, whether or not you want to try to reuse old access paths. All of these things are available to you in bind and rebind, and you need to understand which options are available, what they do, how I can use them in the shop in order to effectively bind and rebind my packages such that I'm getting optimal performance. So when we bind and or rebind, as DB2 optimizes and creates access paths, what's being used? Well, it uses the SQL, it uses the bind parameters, some of which we just looked at. It uses information in the DB2 catalog, the system catalog table, sysIBM, object information, as well as statistics. So you want to make sure that your run stats are up to date and accurate. Using accurate run stats is one of the biggest causes of getting optimal performance. In fact, folks from IBM have reiterated at various IDUG conference presentations that one of the biggest issues in terms of support calls that they get are either outdated, inaccurate, or statistics never being run. And they're people calling up and saying, I have a performance problem. Well, get your statistics right. And you can reduce that burden on IBM. Other things that the optimizer uses: CPU, system software information, memory utilization, buffer pool, rib pool information, query cost formulas inside the optimizer applied to the SQL, and then optionally an optimization hint. So all this stuff goes into the bind and the rebind process for static SQL. One of the things that's important to remember then is that you need a regular rebind strategy, something that is going to say, after so much time progresses, I need to rebind my programs. If I'm not rebinding, then I'm running with access paths that were formulated potentially a long, long time ago. What are the approaches that people use? Again, for static SQL right now, there's daily maintenance where perhaps certain objects that are accessed frequently, the programs that access them get rebound almost daily, or maybe not every day, but every other day, every few days, every week or so, run a run stats, run a rebind, make sure these things are up to date. A global rebind after migration to a new DB2 version. That's almost standard. Rare is the organization that doesn't rebind when they get to a new DB2 version, but some don't, and that causes problems. After installing new PTFs, this isn't an always type of a thing, but really when the PTF says you should consider rebinding, you really should work on rebinding to take advantage of what that PTF is delivering to you. If we're not doing it daily or regularly, maybe it's after so many weeks or so many months, or at the bottom, the worst of all, if it ain't broke, don't fix it. In other words, let it ride until I absolutely have to rebind. Now, why would someone do that? Well, when you rebind, it is possible to get a rogue access path, where a rogue access path is saying what used to work efficiently no longer does. The optimizer was a little less than in terms of the new access path that it came up with. So things perform worse. One SQL statement or two perform worse than before you rebound. And that can be an issue. But in general, that's a bad approach, because what you're saying is, I'm so afraid of one or two bad access paths that I'm going to let everything else in the shop potentially suffer because I'm not rebinding it based on the new statistics. So the best rebind strategy is regular rebinding. That includes a real-time stats analysis, a reorg, and a run stats. In other words, does the real-time stats, there are indicators in there, and when you get to certain levels, is it time to run a reorg and a run stats and a rebind? But this way, you get more accurate, up-to-date access paths, improvements generally, CPU savings generally, optimized performance generally. Of course, you can still get those problem access paths, and we'll talk about those in a minute. Okay, we talked about static, but what about dynamic SQL? Well, SQL executed in DB2 for Z has, for the most of its life, really been static. Some sources define static as embedded, but I'll use a more common definition. Static SQL is SQL whose access path is established during a bind step before the code is executed. Now, a lot of database systems in the market don't really have the same thing as static SQL in DB2. It's somewhat unique to DB2 for Z. Well, they have things maybe that are different, you know, static, that they'll call static, but it's not exactly the same thing. With static, you've got a consistent access path, but it really does require rebinding periodically. With dynamic SQL, it's more flexible, but your access paths can be inconsistent. It's traditionally not as common as static, but it's a lot more common these days than it has been in the past. When we compare dynamic versus static, the access paths of dynamic are created at runtime versus at bind time with static SQL. Again, remembering that the dynamic statement cache is there in dynamic to kind of offset this a bit. The access paths are in the plan table with static, not so with dynamic. Again, we can explain the dynamic statement cache and get that information, but it won't be there beforehand. The bind isn't required. Dynamic SQL is going to use the latest run stats. Well, you know, not always. If you're using dynamic statement cache, it's possible that you're using a cache statement that was done a little while ago, and there have been stats in the meantime, but it's going to be using newer SQL. The other thing to keep in mind too about static, you can use reopt always, causing static to be rebound at runtime, but that's something that's not frequently done in the static realm, but it is possible. You can detect errors at bind time with static. Authorization to the tables is not required with static where it is with dynamic. SQL can change with dynamic. And interpreted language like Rex have dynamic SQL support that's not so with static SQL. So here's some things to look at when comparing whether you'd use dynamic or static. But what are the real drivers of dynamic SQL growth? Well, there's really two significant drivers. Packaged apps, things like SAP, PeopleSoft, Siebel, these commercial off-the-shelf apps predominantly use dynamic SQL. And they do that because it's much easier for them to be able to support multiple underlying DBMSs. So they support Oracle, or they support SQL Server, or they support DB2, and they can make changes to their code without always having to have different versions and levels of SQL that work only against Oracle and this only against DB2. So the static binding isn't something that these ERP, CRM apps generally embrace. Now you may have a packaged app that supports only DB2, that's not one of these big ones, and then it does do static SQL, but those are in the minority. So packaged applications drive dynamic SQL adoption, but also modern applications. These are ones developed on distributed platforms or designed for the web. These developers that are more used to using GUI-based IDE in order to develop code. They support tools that provide better support for dynamic APIs than for static SQL, if they even support static SQL at all. And many developers today don't even sign on to an ISPF screen or onto the mainframe. Yeah, you got to have an ID to get to the mainframe, but you're not logging into ISPF. So a Java, a .NET developer is using their desktop with a point-and-click, web-based, browser-based, GUI-based interface to do their development, and static isn't part of that world. So, if we had to summarize here, there are distinct reasons static SQL is dominated for so long. I mean, one of the hallmarks of the mainframe environment is consistency, and then static SQL establishes that access path during the bind, and then that means it's known before the code ever runs. Well, it's known if you run explain against the package. A characteristic of static SQL that's sometimes overlooked is the simplified security. The user of the app doesn't need specific privileges for each of the objects in the program. But static doesn't meet all the requirements of modern development. I mean, the bind process requires time and some work, and it can slow development, especially early on when the code is recompiled frequently. And many of the application development platforms that we've seen over the last decade or so are more functional for dynamic SQL, or only functional for dynamic SQL, as we just discussed. So with dynamic SQL, we always get access to the most current run stats, or almost always, and we also have the ability to modify the SQL on the fly as needed. So what are the best practices that you can adopt? Well, I would say you need to build quality assurance steps into your development process and into your production turnover process to make sure that you have well-formed, efficient, and effective SQL statements being built and migrated into your production environment. You know, a lot of times, I can go back to the DB2 version 1 days, and when I was a DBA in the earlier days of DB2 at a Midwest bank, we had procedures where every piece of code, every program that was going to move into production had to go through a code walkthrough with the DBA. People don't do that anymore. There's just not enough time, and there's too much code, and sometimes the DBAs don't necessarily understand the environment that's being developed for. Do all your DBAs write Java or C# or understand .NET? In many cases, stuff gets turned over without due diligence. So the more you can do in an automated manner can help, and we'll get to that. Number 2, be prepared to support and maintain applications that use dynamic SQL. This requires tools and processes that can identify and optimize dynamic SQL statements. So with these best practices in mind and all the things we just went through with regard to static and dynamic SQL and the rebind process, I want to introduce to you a couple of solutions from DataKinetics. The first is DB2 QA, which is automated quality assurance for your DB2 applications. Okay, so what is SQL quality assurance? What QA can do is establish standards and guidelines for your SQL in your dynamic applications. I'm sorry, in your DB2 applications. And it can do it for both dynamic and static SQL statements. So you can have these standard rules that get analyzed for any program that you can assess and then either allow or disallow programs to be moved into production based on whether or not they conform to the rules. This prevents poorly performing SQL from spreading, sometimes from even getting into production. It can ensure the response time of your transactions. Remembering back 2 seconds, people are going away for your web-facing, customer-facing applications. And it can improve your developers' coding practices because it makes them aware of the recommended SQL standards, because all their code has to go through that process. What DB2 QA does is analyze and explain and perform checks on all of your SQL code. You can do it from source code, from a DBRM, from DB2 catalog-based SQL, from dynamic SQL. Type in a statement and let it do its thing. It evaluates that code against a provided knowledge base of SQL quality rules. That knowledge base that comes with QA contains more than 300 rules, which are extensible. You can modify the rules to your liking. You can add your own rules. You can manage multiple sets and versions of the rules. With QA, SQL that doesn't conform to the rules get identified for tuning and improvement. This allows you to eliminate bad SQL during the development phase. Remember, the earlier in the process, the less costly it is and the easier it is to fix, to remediate the code. You can use it to reject bad SQL. That's SQL that doesn't conform to the rules in the knowledge base before it gets to production by putting QA into your migration procedures. So you've got your programs that go through the precompile and the bind process. You can inject DB2 QA into this procedure so that as part of binding your packages, it examines the rules and rejects those packages that have bad SQL in it. So it identifies where the problem is, and it says this needs to be corrected because it doesn't conform to this particular rule, thereby enabling you to get better quality SQL in your production environment. What about dynamic? Well, with dynamic, you're not going through that bind process, so sometimes dynamic SQL is going to get into the production environment. Now, if possible, you can collect the SQL statements that are being built by your dynamic applications before they go to production and feed them into QA, and then it can go and apply the rules to them. Or you can grab the information from the dynamic SQL cache and run that through QA. Anywhere you can get the dynamic SQL from, you can apply the QA rules to them, which will allow you to review what's happened, fix the SQL, and examine it again for compliance. So the benefits with automated quality assurance, remember I said, in the early days we went through code reviews where the DBA methodically went line by line through the program, and that doesn't happen anymore. QA can automate that process, sort of give you a DBA in a drum, right, where DBA would look and find things that were not up to snuff. Here we're allowing an automated QA process with rules do that. Well, additionally, we can track patterns and trends. We can audit and assess the most frequently violated rules. And in that case, say this is where we need to train our developers a bit more. There's the explain feature, which gives a more detailed explanation of access paths. There's the capability to mimic the production environment and test, with production stats being moved into the test environment. So a lot of tools that work together to ensure the QA process for you. You've also got an ISPF interface as well as a GUI Eclipse plugin. So if you want, you can purchase the optional GUI Eclipse plugin to allow folks who aren't comfortable with the traditional mainframe green screen interface to interact with and benefit from QA and its rules. There's also a batch utility that can be used to apply to batch processes. This slide kind of highlights what QA can do and automate for you. I'm not going to read through it other than to say, you got your SQL source. It can come from multiple different places. Apply it through the QA functions, checking against the rules. In-house and purchased applications can benefit from it. You can look at the explains. You can migrate your run stats. You can monitor, trace, and cache SQL trace to capture information that can then be monitored. And there's production environment automatic QA, where you can mass check new packages, giving you a whole slew of benefits that results in better performing transactions, better developed SQL, realistic run stats, standard quality assurance, and the ability to rest a little bit more comfortably because you're locating violations before they get into production. Wanted to briefly show you a few of the screenshots. I'm not a big fan of screenshots and presentations, but some of them can be beneficial. This shows some of the rules that are checked, another rules that are checked. There's a whole series of rules that get checked by the QA product. And you can also take a look at QA results. Here we see information found no index used in this step. A table space scan was used. This is going to throw out a warning in this case. Here's a warning. Joins coded in pre-version 4.1 format, so the comma-separated tables instead of the on. Some of these rules you may want, some of these rules you may not want. Again, fully extensible. You can modify them, eliminate them, add to them. That's one of the products. The other one that I want to talk to you briefly about is QA+. Again, this is works in conjunction with QA and improves the quality of your SQL, this time mostly for dynamic. Now, many aspects of tuning dynamic are similar to tuning static, right? You find the problematic SQL, you figure out, oh, okay, who ran this, what program ran it, if that's possible. Then you explain the statement, tune the statement, and repeat as necessary. So you have to build your best practices for tuning dynamic SQL and make sure all of these things are available to you as you adopt and run dynamic. But there's no DBRMs or packages or access paths in the plan table that you can use. So how do you find the problems? Well, a lot of times it starts with a phone call. Ring, ring, hello, DBA, things suck, help me out. And sometimes it's not any better than that. Maybe you get a little bit more information about what transaction they're trying to run, what the issue is. This ran quickly yesterday, and now it's out here spinning. It's taking, 10 seconds, whereas usually it's sub-second. Usually, though, you're finding this out after a problem occurs, and it may require costly traces. And it's not always obvious who executed the statements, but it's useful to know if you can determine it. Why would you want to know that? Because it helps you gather information about the query, what parameter markers and host variables were used. If it's still running, you want to warn the end user before you kill the thread, and you want to remediate by getting the user to stop running that particular query or form of that query until you figure out what the performance problem is, if that's at all possible. So the more information you can gather here, the better. And here we bring in QA+, which is a cache monitor. And it can be set to automatically capture dynamic SQL from the dynamic statement cache. You can set as a duration or unlimited capture, and it'll capture your SQL from any source: homegrown apps, QMF, distributed ERP, web-based Java, .NET, whatever. It's one service to monitor all your dynamic SQL. You can then organize and optimize your dynamic SQL. Because you've captured this through the cache monitor, you can run that SQL through QA, the product we talked about earlier, for quality improvement. So QA Plus will capture our dynamic SQL. QA will run it through the rules. It will identify similar SQL statements and treat them accordingly. You can tag and track SQL statements and produce multiple reports across these SQL statements that have been captured by QA+. What are the benefits? It's efficient, doesn't require expensive traces, SQL traces, to be turned on. Gives you dynamic SQL information at your fingertips. You can report on useful information about performance problems and heavy hitters, and you can issue alerts when critical dynamic SQL is executed. And by applying and capturing the SQL, running it through the QA rules, you can save CPU, delay upgrades, identify problems much more quickly, and again, if we take a look at this picture that I showed earlier, this becomes a lot easier. The new part is over here. QA Plus captures the dynamic SQL, which gets fed into QA, and then goes into this process where we review, fix, examine, capture, run, review, fix, examine. So we've got an improvement cycle that we've put into production by combining QA Plus to capture our dynamic SQL and QA to analyze and deliver improvements to that SQL. Again, a couple quick screen captures, QA cache monitor here. We see some detailed information showing total number of executions of a single statement, get page asynchronous reads, writes, and so on. So we can see the statement ID, and we can dive down and get more detail. Here we've got a report showing hot consumers over all measured periods with the accumulated data. We've got them split into groups: primary auth ID, SQL ID, current SQL ID, and QA Plus groups. They're unique to QA Plus, these groups, and you can maintain them by administering the user definition to define which users should be grouped together, and then they show up in these groups, which could give you these performance characteristics for the important hot consumers, if you will. Okay, that brings us to the end of the prepared material. I want to briefly mention here that DBIQ is a family of products. I've talked about two of them today in conjunction with improving your SQL performance. That's QA and QA+. But DataKinetics also offers index administration, workload detector, package management, and migration aid, which can further improve the efficiency and effectiveness of your DB2 performance management and database administration capabilities. So keep that in mind. Again, we talked about QA and QA Plus today. So with that, I'm going to turn it back over to Leah and see if there's any questions for us.
Great. Can you hear me?
Yes.
Okay, super. As a matter of fact, we have quite a few questions. I'm not sure we're going to be able to get through all of them. But let me go ahead and start here, and we'll see what we can do and still meet our time frame of 3 o'clock. So first question from Siva. When order by or group by are present, does the index need to be created on the columns to improve performance? Or is it better not to do order by or group by in SQL and instead do it in a batch job after getting results from SQL?
That's a loaded, interesting question.
I thought I would start with the easy ones first.
Well, first of all, I would say that if you're doing order bys and group bys on sufficient amounts of data, that it makes a lot of sense to try to have indexes to support that where and when you can. In some instances, it is going to potentially be better performing to get all of the data unsorted and run it through a sort program that's optimized for sorting. In some cases, where that trade-off is in terms of number of rows, in terms of the product you have for sorting, is something that can be difficult to arrive at, and you might need to do some testing at your shop to see where the benefit can come in. So I would recommend first to make sure you've got the indexes for the group bys and order bys, and that DB2 is taking advantage of them by looking at the explain. And only after you are then seeing suboptimal performance that doesn't meet your objectives should you examine looking at taking the sort out and sorting afterwards. Now, a lot, too, is going to be based on what else you're doing in the SQL statement, what else is being done in the program. Are you breaking apart multiple programs in order to do this? Is the sort required to be moved to another part of that program? So there's nothing that I can say, hard and fast rule, here's where you do it, here's where you don't. But it's something where I wouldn't say never do that. By that meaning, run it through a sort program like df sort or sig sort. Did I waffle enough on that answer?
No, it was great. Okay, next question. We have rolling monthly views on physical monthly tables, which are loaded and updated every month with millions of records. After load update, we have run stats. COBOL programs use the views to get results. My question is, do we need to rebind COBOL programs after run stats? My doubt is we use views instead of tables, and so does run stats help. Run stats help. You want me to repeat that?
I think I got it.
Okay.
Rolling monthly views, populated every month, run stats run after, but rebind not run.
Correct.
Okay. A lot is going to depend on exactly what you're doing to the nature of the data and how dramatically different it is from past months. If the data, even as you roll it over, if it's still the stats that were there are close to what are there now, it may not warrant running warrant running rebind every month. On the other hand, if you are changing the data significantly, so in one case the month has millions of rows, the next case it has thousands, you should be running rebind. There's nothing magic about a view that says run stats don't matter anymore. All a view is a virtual table on top of an actual table. So the data, if the data underlying it is changing, then that is what you should be basing it on. So if all you're saying is that the view is what's changing and not the data, then it's not a big deal. If the data itself is changing, then and it seems like it would be because you're running run stats, there'd be no reason to run run stats if the data didn't change. So if the data is changing and you need to run run stats and it's changed significantly enough, you should also be running rebind.
Got it. Okay, next question.
Do we have any yes or no questions?
No, but they are getting shorter.
Okay.
Okay, for the next shortened question, for our COBOL DB2 programs, we are using bind options like degree and reopt. Always use reopt. Are these options okay? Or any other better options that we can use?
Well, both the options are fine if you're using them to do what they were designed to do. I mean, degree is out there in order to allow you to have parallel access. So if you are wanting to run with multiple degrees of parallelism, in other words, have the SQL statement be able to run against data in multiple partitions at the same time. It doesn't have to be partitions, but that usually helps if it's partitioned. Then degree of more than one, degree any, can be helpful. Reopt, again, depends on how you're using it and which particular reopt you are choosing. If there are certain SQL statements that can benefit from reoptimization at runtime, then the reopt parameter is one that is absolutely worth using. It's hard to say whether, without looking at your SQL or your actual needs, whether or not you're using them appropriately or effectively, but yes, they're both fine options. They both can be extremely helpful in, with certain types of applications, and if you're using them the way they're designed to be used, keep on going.
Okay, great. Okay, is the DB2 QA product only available on ZOS, or is it available on the distributed side as well?
The DB2 products are ZOS, DB2 for ZOS only.
Yep. And does the QA Plus product require IFCID 316, 317, 318 turned on? If so, what is the cost of the IFCIDs? You might not know that one.
I don't know that off the top of my head, but I'm going to guess that it's going to require some IFKIDs turned on in order to capture the dynamic SQL the way it does, and that there will be some overhead there, but starting traces at the IFKID level like that is generally not the performance detriment that the trace classes can be. So again, without knowing for sure, I don't know what exact IFKIDs IQQA Plus requires, but my guess is it requires some of them, probably the ones you mentioned, and that there will be some overhead, but it depends. A lot's going to depend upon how much dynamic SQL is going through the system and how much as to whether you can tolerate it. So Leah, my preference there would be to have Rick or somebody at DataKinetics investigate that and get back to that customer with the answer.
Yeah, so Greg, if you're listening, we will give you a call. Okay, this is another QA-specific question. It says, QA Plus sounds interesting. Is this using a documented IBM exit to extract the SQL? Is it new? Never heard of it before. Someone else would be using it. Yeah, we're going to get back to that person as well, because Craig's really focused more on the SQL things. Here's one. I do a break on a column in my QMF report. At the end of the report, I need to find how many breaks are in the report. How do I do that?
I would think that, I'm thinking back to the old, it's been a long time since I used QMF, but I think with QMF you can take that report you generate and save it off to a table, and then based on like if you have some way to identify the break in that row, I mean, is there an identifying feature of the break, or is it just more rows? If there's some way in the query you could put something identifying it there into one of the columns, that way you could then query the table that you created of the report, counting the occurrences of that column using the count function. That would be my knee-jerk reaction to how I might approach that.
Got it. Okay, good. Okay, Jim, I will personally get back to you on your question, and you know what, the questions are flying, and unfortunately we're out of time. We promised everybody we'd be done by 3. So I want to thank everybody for your time. We will personally get back with everybody to answer all of their questions. But thank you for your time. Hopefully we gave you some insight into DB2 SQL, and you gained a little more knowledge than you had before we started the webinar. So we appreciate everyone's time. We wish you a great weekend, and we take any advice y'all have on future webinars. So if you could send us an email to let us know what subject matter you all would be interested in, we're interested in hearing your comments. So again, thank you for your time. Have a great day. Have a great weekend. And Craig, thank you as well.
Thank you, Leah. Goodbye, everybody.